Hi everyone. I'm going to show you assignment 4 just briefly what we're going to be doing there, and hopefully it'll all make sense. So we're doing essentially the same assignment as last time. It's not trying to be crazy. It's trying to show two new things. It's trying to show you how to think about or test your code. Now that we have functions, we can actually do that. Otherwise, it would be a royal pain. If I had to copy and paste the same code over and over and over again, it would be, and I had a mistake in it, I had to change it in all of these different places. If I had to debug it, I had to figure out which of these, all of this code made, how it works. If I have a function, I just keep calling that same function over and over and over again. That's what we want to be showing you. We want to show or demonstrate that functions are useful for testing purposes. They're useful for modularizing your code so that you know exactly what this thing does over there, like my absolute gets the absolute value of some value. And we're also showing you how you can reuse code, how functions can call other functions, which we're going to be doing with calculate the volume of a cylinder. We have this nice function called calculate the volume of area of a circle. Wink, wink, right? And to calculate the volume of a cylinder, it's the area multiplied by the height. So we can calculate the area. We got the height. We're good. So we're going to be making a whole bunch of functions. In fact, here are the function prototypes that we're going to be using. This is the IOUs. So we can call these functions, but they got to be defined somewhere further down in my code. This is just foreshadowing, if you will, of things to come. So these are the functions you're going to be writing for this assignment, and you're just going to fill in what they look like. It'll be very similar to what we did in for the last assignment, but I want you to feel comfortable making functions. It's such a critical thing for the rest of the course that I want to make sure you know what the problem is, you understand the problem, and you're just applying it in a different domain, in a different way when you get here. Okay, so one of the things, you're going to be taking in some input from the user, like the height and the radius, and then afterwards I suggest, or I'm telling you to, call it on a bunch of stuff, right? Get the radius of the circle, get the cylinder volume, get the sphere radius. Fine. You could test your round function. So you can call an assert, for example. Call your round function, simple round. Check the math library's round function and see if they return the same value. Great, right? This is going to return an integer. It's going to return, I guess, 3 in this case. This thing is going to return an integer, should return the same value. This is definitely going to return 3. This is definitely should return 3. 6 and 6. Okay, after I've done that, then I might want to have a couple other output statements, maybe like printf statements to say, hey, look, this is what happens, if I do this. Here's me testing my absolute value. And maybe what I want, and I don't have it in here, but I should put some extra things in here, right? I calculate the volume of a sphere, a cube, a circle. Let's call those functions again with a printf statement, make sure they work. So I'm going to actually add this afterwards. So you can calculate the volume of a sphere, especially if you know what the volume should be. You can call it 20 times just to make sure that the math works correctly. The idea is that you want to be able to get feedback. You want to be able to see that your code works before you move to the next part. So you write a bunch of printf statements that say what the volume of your cylinder is for not different inputs from the user, just hard code values. See what happens. And that way you can test your code. It doesn't take anything to do. You're not having to type it in each time you run the program. You just run the program with a whole bunch of inputs, different inputs, calling the same function, getting an output. So I may have like 12, 6 to 12 different printf statements, let's say, saying what the output would be for these different inputs. And that way I can test my code without having to type in every single time. All right. And other than that, I don't want to give away the answer, sorry. Other than that, that's essentially what we're doing for the assignment. There's not a whole lot of craziness here, but it does allow me to, let's say, call something like, let's do this. I'm going to use that same function. I'm going to use printf. New line. All right. And I'm going to have a cube with side of length blah, and I'm going to use 4. And what would this be? 4 times 4 is 16. Crap, I don't want to do 4 because it's good. I have to do math in my head. 36, no, 64? 64, it's got to be 64. Oh my god, I should know this off the top of my head. 4 times 4, 16, times 4 is 32, 64. Okay, so let's do 4. And this is 64.0. Oh, it's not 64.0. I want it to be 64. Should be. I want to predict what I'm going to get. And I'm going to call my function right in here. I can do that easily enough. So I calculate volume of a cube. And I'm going to put 4 in here. And that should do it. All right, I'm going to compile. Oh, I can't even. There we go. Let's compile. Oh, I got some warnings. Converting from argument double. That's fine. I want to check out some of these things. So this is a floating point number. Calculate the volume of the cube. Returns an F. So it's not. That should be an F. Possible loss of data. Okay, I can double check on that. What line is it on? Okay. Argument conversion from double to int. Possible loss of data. Do I actually have a line number on it? No, I don't, but I want to see what. I should have a green line somewhere around here when I try and do this. Actually, I have it down here. Right there's. I don't want to solve that one because now you've just had a chance to go frame by frame and look at the video. If you're going frame by frame, I mean, you're wasting your time. It's slower to doing that than writing the code. All right, everything's working. I have 100% success. Now that I've compiled it, now I'm going to run it. And this is the kind of thing I would expect to see. And let's plop it up. So let's say 2. And the height is going to be 4. And these are the values I would get from all these calculations, including the cube of length 4 has volume 64, right? That's what I expected. Oh, wait, it did the calculation for me. I predicted it was going to be 64. I got 64. Hey, we're good. My code works. That's what I'm looking for. That's the kind of thing that we're doing. That if I call my absolute value, I get 8.2. If I call the traditional built-in, not built-in, but in the math library, absolute value function, I get 8.2. Great. That's what I'm looking for, is the kind of thing that I'm looking for output. It's not exactly necessarily this exact wording. It's I'm testing my code to make sure it works. Okay? And because I have a function, I only have to do things like this. There's no copying and pasting anywhere along the lines here. I just I can copy and paste the same printf statement a bunch of times, but I'm not repeating my code a bunch of times. I'm just calling the printf statement a bunch. Easier than trying, duplicate code all over the place. So I could do the same call 12 different times with 12 different inputs and see what I get. That's what I'm looking for. Okay, not 12, but you know what I mean. All right, thanks everyone, and hopefully that made some sense of what we're trying to get across for assignment 4. Thanks.